So this is the last lesson for ES 10 for everyone that's AP testing or just needs to rewatch this. Here we go. So we've got 6 people here in class that are going to be asking questions and stuff. So if you hear anyone else, it's probably sad. So
yeah, it is.
Sequences and summations. So first thing we're going to cover is sequences. Sequence is a function whose domain is a set of all positive integers. Usually a sequence is represented by listing values in order. So 1, 1/2, 1/3, 1/4, 1/5. You see that we're not going up by a constant amount here, but we can definitely see a pattern. So we want to write the first 6 terms of each sequence. So this is defined as s sub n equals -1 to the power of n minus 1 over 2 minus n. So the first term I would want to find would be s sub 1. You can see there that the n value is now replaced with 1. So in my equation, I'm simply going to replace n with 1. First thing we need to do is 1 minus 1 is 0. -1 to the power of 0 is 1. And then 2 over 1 is 2, so 1 times 2 is 2. So the first term of my sequence is 2. Now we'll do the same thing for s sub 2. Notice again we just replace the n with 2. So here we can see that we're going to have -1 to the first power is -1. And 2 over 2 is 1. So my second term is -1. S sub 3 is my third term. So I simply plug in 3 for my n. So we would have -1 to the second power, which is 1, times 2/3 is 2/3. Now our fourth term. We plug in 4 for all the n's. -1 to the third power is -1. 2/4 is 1/2. So we get an answer of -1/2. And then our fifth term is -1 to the 5 minus 1 over 2 over 5. -1 to the fourth power is 1 times 2/5 is 2/5. Oh, did it say the first 6 terms?
Yeah.
So for the sixth term, we would take -1 to the power of 6 minus 1 times 2 over 6. -1 to the fifth power is -1. 2/6 simplifies to be 1/3. So that would be -1/3. So my first 6 terms of my sequence would be 2, -1, 2/3, -1/2, 2/5, and -1/3. You see that my sign alternates between positive and negative because -1 to an odd power is negative, and the -1 to an even power is positive. So that's what makes the sign switch back and forth. Now let's try example 2. So we're going to find the first term by plugging in 1. So -1 to the first power times 1 plus 1 over 1. -1 to the first power, of course, is 1. 2 over 1 is 2, so we have -1 times 2 plus you is -2. The second term would simply be -1 to the second power times 2 plus 1 over 2. So that's going to be 1 times 3/2. For s sub 3, we're going to have -1 to the third power times 3 plus 1 over 3. So that's -1 times 4/3. The fourth term And by now we should see the pattern. That we started out with -2, and then we did positive 3/2, negative 4/3, positive 5/4. So we can see here that the fifth term is going to be negative 6/5, and our S sub 6 will be positive 7/6. A recursively defined sequence is a sequence in which each answer depends on the number before it. So in other words, in order to find the second term, I have to know the first term. In order to find the third term, I have to know the second. So in order to find the 50th term, I have to know the 49th. And in order to have found the 49th, I had to know the 48th, and so on and so forth. So these are very hard to find a large number in the sequence, as opposed to our first examples where if I wanted to find the 50th term, I could have just plugged in 50. So here we want to write the first 5 terms of each sequence. S sub 1, so the first term, they already give us is 1. S sub 2 is equal to 2 times S sub 2 minus 1 plus 1. Here you can see in the subscript, 2 minus 1 is 1. So this is saying 2 times S sub 1 plus 1. Well, you can see that S sub 1, we already found up top here to be 1. So this is 2 times 1 plus 1, which is 3. Now what you should start to realize here is that S sub n minus 1, this always stands for the previous term. Or your previous answer. You can think of it as, on your calculator, if you hit second negative key, that you're bringing up your previous answer. So then S sub 3 would be 2 times our previous answer, which was 3, plus 1, which is 7. S sub 4 is 2 times our previous answer, which was 7, plus 1, which is 15. And S sub 5 is 2 times your previous answer, 15, plus 1, which is 31. So my sequence here would be 1, 3, 7, 15, 31. Now we're ready to work on example 4. You can see here that I give you the first 2 terms, so I know the first 2 terms, but here we have u sub n minus 1, which is your previous term. So then u sub n minus 2 is the previous term. So, to find u sub 3, whoops, sorry about that, u sub 3 would be equal to u sub 1 plus u sub 2. So u sub 3 is equal to 1 plus 2, which is 3. U sub 4 would be equal to u sub 2 plus u sub 3. Again, our previous plus our previous answer, so that would be equal to 2 plus 3, which is 5. And then u sub 5 would be equal to u sub 3 plus u sub 4, which would be 3 plus 5, which is 8. So listed out, those would go 1, 2, 3, 5, 8. So you can see here, 3 is made up of adding 1 and 2. 5 is made up of adding 2 and 3. 8 is adding up 3 and 5. Our next term would then be 13. The term after that would be 21. So now we want to find the sum of the first 7 terms of the sequence. So we're going to first find the first 7 terms. You notice that this is not recursively defined. So we're simply going to plug in 1 to find the first term. you'll get to where you don't need to write down these steps, to where you just look at the problem and you plug in the numbers and you get the answer. So -1 to an even power is 1. 4 over 1 is 4. So my answer there is 4. S sub 2, so I'd plug in 2. Would be -1 times 2, which is -2. S sub 3 is -1 to the power of 3 plus 1 over 4 times 4 over 3, which would be positive 4/3. S sub 4 is -1 to the 4 plus 1 times 4 over 4, which would be -1. S sub 5, -1 to the 5 plus 1 times 4 over 5 is positive 4/5. We would get S sub 6 is -2/3. Okay, so now we need to find the 7th term, since it said to add the first 7 terms. So -1 to the power of 7 plus 1, that would be positive, times 4/7 is just 4/7. So now I need to add those first 7 terms together, because that's what it wanted me to do, is find the sum of them. So I want to take 4 plus -2 plus 4/3 plus -1 plus 4/5 plus, so I got our first 5 terms, and then we need -2/3 and 4/7. We could do this by hand, get a common denominator, but we've got a calculator, so let's just do that. So 4 minus 2 plus 4/3 minus 1 plus 4/5 minus 2/3 plus 4/7. Math, enter makes it as a fraction. We get 319 over 105. So that would be the sum of our answer, or if we wanted to write it as a mixed number, that would be 3 and 4 105ths. 105ths. Sure. So a lot of times we need to do problems like that last one where we're adding up many variables. This is where we will use summation notation, or sometimes you'll hear it referred to as sigma notation. So that's because this sign here is the capital letter sigma. It's just a way for us to write the summation of several terms. So here we give an example. So this is our formula, 4n. So that's another way of saying S sub n equals 4n. And we want to find from 1 through 6. So we're going to start at 1 and go all the way through 6, and then add those answers up. So we can see when I plug in 1, I'd have 4 times 1. When I plug in 2, I'd have 4 times 2. When I plug in 3, 4 times 3, and then so on and so forth to get 6. So then I would simply take 4 plus 8 plus 12 plus 16 plus 20 plus 24. And we could plug that into a calculator, or we could just take 28 times 3, which is 84. I got the 28 from adding 4 and 24. You can see all these pairs add up to 28.